Hi, my name is Adam. This is Jordan. We're both Android engineers at different companies. I work at Travel Perk, where we build business travel software. He works at Marks and Spencer. They're one of the biggest retailers in this country. And we're going to talk about developer productivity. So to give you a bit of background about us and what we're going to talk about, so we both work on platform teams at our respective companies. We have mid-sized mobile orgs, so about more than 30 mobile engineers, I think. Yeah. And our team's focus is improving developer productivity at our companies. So that includes anything from our build times, CI, internal tooling, rules about code style, modularization, basically anything that would empower our product teams to build features that the business needs. So that's us. And the things we'll talk about they came out of necessity to our organizations. They don't have to be things you don't have to build the same things. They don't have to be things that you'll find useful. But we hope that some of these ideas will be interesting to you, and maybe you can walk out of here with something that you built for your own teams.
Cool. So I'll quickly go through what we're going to cover over this talk. So we're going to alternate between 3 projects we worked on. So Adam's going to start off talking about automating bug reporting and triaging of those bugs throughout the teams in his business. I'm going to talk about rolling out convention plugins at M&S and how they've been helpful for us. Adam's going to talk about automating their release trains, which is super interesting. I'm going to talk about reporting build times. So talking about how we haven't any clue about how long it takes for the app to compile. Adam's going to talk about improving the CI workflows. And finally, I'm going to talk about linting. So I'm going to hand over to Adam.
Cool, thank you. All right, so I'll talk about automating our bug reporting and triaging. Triaging, that's a difficult word. So a problem that we have, or used to have, is I think this is probably similar to a lot of your organizations. We have a lot of squads that own different parts of the code base. And we wanted a way to find out when a crash happens, and we wanted a way to attribute that crash to teams as soon as possible. But another problem we have is each one of those teams has their own Jira board, which will come in later. So we tried a few things before coming to what we'll talk about at the end here. The first thing we tried is the Crashlytics Jira integration. That comes out of the box, I think. But it didn't really work out for us because each squad having their own Jira board meant that we couldn't directly use that linking feature because it can only link to one Jira board. And we have a lot of custom fields that you have to set for our tickets. And that integration doesn't work. It doesn't know how to fill in any of these things. So that failed immediately. We tried Slack notifications. I think on Crashlytics, you can set it send Slack notifications to some channel whenever a crash happens. But those got noisy real quick, and people basically stopped looking at them. Another thing we tried is assigning firefighters. So different squads would have a person assigned to check Crashlytics once every day, or one person would check it for the entire organization. But that also wasn't really efficient because that person, if I check it today and I see a new crash, hopefully we don't get that many crashes, but you'll see a crash, and you have to figure out which team owns that crash, and you have to check if some member of that team has already seen it, if they've created a ticket for it, if they told people about it. It's a lot of work, and potentially you could do the same work that someone before you did. So we did that for a while, but it was really inefficient, so we decided to roll out our own tool. So what does it do? So we built this small JVM app, and it talks to the Crashlytics API. Well, they don't have an API. We talk to BigQuery, and we query it on a cron job. So every 45 minutes or so, it'll check if there are any new crashes. It'll check if there are any new crashes. It'll parse the stack trace to see which team owns, to try to figure out which team owns that. That works for us. That took a lot of iteration, but now it works 99% of the time. So the way it'll query, it'll ask BigQuery like once every 30 minutes, 45 minutes, see if there's anything new. If there's something new, it'll try to figure out which team owns it. And then it'll talk to OpenAI to try to find a solution for that problem. So it'll give it, oh yeah, we weren't going to make it through this talk without talking about AI. So yeah, it talks to OpenAI, gives it the stack trace, gives it a bunch of files to like figure out where it's happening. Hopefully gives you a solution. And then it opens a detailed Jira ticket on that team's board. So it gives them the stack trace. It gives them the affected app, like the affected version of the app, the affected platform, and it checks. Obviously, it doesn't duplicate any of this. So if a ticket has already been created, it doesn't create it again. And it sends them a Slack notification. So instead of sending notifications to like a public channel, it now knows which one to send the notification to. And a lot of teams, like some teams have different rules about their tickets. So some teams want you to automatically assign a bug a high priority, or they automatically want you to move it to the next column, or they have custom fields that they want you to fill out for them. And it allows us to do that as well. And we also use it for Datadog. So we use Datadog for monitoring other things like our SLOs. And we have monitors that track these things. And if they fall below a certain threshold, we also know when that happens. And we immediately tell that team that this monitor that you own for this SLO is in alert or something. And so we let them know when that happens as well. And it works for both platforms. And this is a screenshot of what it looks like. So we'll tell you like the platform in the title, the stack trace. I can't see this. Yeah, the platform, the affected version, and that's the AI stuff. We send it the stack trace and the file that it happened in, and it tries to give you a solution. And I think in that case, that was the solution that you needed. So that saves you time that saves the firefighters time, and it saves the developers' times as well, because they don't need to research anymore. And that's already, like, you find that in the morning, you find that as soon as it happens. Yeah.
Cool. So I'm going to talk about convention plugins, which might be something you're starting to hear more and more about. It's something that's come from like Gradle. It's about how you can reduce the duplication you have through your build files. So I want to sort of talk about how we've adopted them at M&S and how it's been useful. So at M&S, we're fully on the modularization hype train. When I joined, we had about 90 modules, and now we're about 160. So as you can imagine, like, it's been growing pretty quickly, and we want to keep that growing. We also have many apps, many code bases that we're starting to look at. So there's another 30. So we have a retail application. We have another like 30 apps within our code base. Sorry, like our estate. So it means a lot of places where we want to put some build configuration and have it consistent. And the build configuration pre-convention plugins involved a lot of duplication, a lot of inconsistencies, and like it's a bit of a maintenance problem. So if we wanted to, you'll see shortly, if we want to update from Java 1.8 one day to Java 11, that was going to be a bit of a hard job for us. Now it's going to be a lot easier. So yeah, the solution was we want to ensure we can scale. We want to make it so that product devs can just not think about build configuration, just put a few lines of code in a build file and get to work on making features. And yeah, to adopt this, we used Gradle convention plugins. So I want to take you through some more of the problem and how it looks for us now. So like I mentioned, we had a lot of duplication. They look like small things, but they become a bit of a problem over time when it like compounds on top of each other. So for example, pretty much every build file contained this like compatibility options block. And it also, some of them contained one that looked like this. So we had a mixture of like variables and a mixture of strings, which, yeah, not a big deal, but if you want to change this string to 11, it's quite hard to do like reliably and safely. For the Android library modules, so projects, we had to include 2 plugins. Not a big deal, but across like 100 modules, that's like 200 plugins which have been applied, which becomes a bit of a problem as you scale more and more. And I think the one that you'll probably see a lot, this has actually been solved by Google now, but pretty much every Android module had to define the compile SDK version, min SDK version, target SDK version. And we were a little bit behind in how we should do this, but we did have variables, which is great. That made it a bit easier for us to update. But it's very easy to forget to paste one of these into a build file. So we had a bit of a, sort of like a culture of, we had a lot of copy and pasting build files. And that wasn't like scalable. So yeah, just to recap, we had duplications, inconsistencies. We had applied scripts, quite a few of those, and they were quite crucial. So we had to apply scripts to like have Jacoco run and get code coverage. But if you forgot to apply it, the unit test would never run on the CI, so it's kind of a big deal. And it's very easy to forget to apply that. Yeah, all this adds up into maintenance headaches. So the goal was to have build files that look something like this: one plugin block, an Android block, and just dependencies. It's a long-term goal, and we're almost there now. There's a bit more work to do, but the hope was that we could go back to copy and pasting build files, but they'd be maintainable, as in like copy and pasting what people are familiar with. So kind of want to go into briefly on how we did it and how I think it could be useful for some devs here if you want to adopt that in your teams. We started off with a script. So this isn't going to be a tutorial on how to like use conventions, but you can create a new included build, and you can start by writing a KTS script, so it looks just like a Gradle file you'd be used to. And that worked initially because it's a new concept. You want to like bring it into the team and the business. And this then turns into a plugin which you can apply. The next step was to use an actual Gradle plugin. So that means bringing things into classes, extending the plugin type, and then you can start to write code how you're a bit more familiar with it, so not scripts necessarily. And this has some like massive benefits. Like you can unit test this, you can run integration tests. That's like should be good for the business because you can test all of your build configuration. So what were the benefits? We removed thousands of lines of build configuration from the project. So talking about 90 modules initially. In the first PR, we were able to remove 1,500 lines of code, which is a big thing. It's like less we have to maintain in the platform team. It's less code people have to think about. We can roll out new build features with low effort. So something I want to talk about later on is like linting, spotless and KT lint. We were able to roll that out with just 290 lines of code, and then that went out into every module, and we can lint everywhere, which was great. And like I also already mentioned, we got like unit tests, which has been really useful. I've just seen I have a slide where I didn't do the code highlighting, which is a shame. But this is an example of what a build file looks like now. I didn't show an aggregate example of a build file before, but you could pretty much never copy this into a slide without having to go to like 11 font size. I also have some duplicate slides, my bad. Lessons learned, check the slides before you give the talk. Something I found I think was useful is like evangelizing for like idiomatic Gradle concepts. Like it helps within the business when you're using things which are recommended by like the tooling you use, and it makes life a lot easier. One very niche thing which I haven't really covered is you have this included build. Often you put it in this file called a build logic file. If a module, you keep it within your code base, and it's great for like developer like friendliness. Everyone can see what you're doing. However, it has a big impact on build times, configuration time. So it's good to move this out and version it. And also think carefully about what you include in your conventions. You don't want to put everything because it makes it hard to like move it into other projects. So those are the things that I would consider thinking about. And so finally, who would benefit? I think because there's different sizes of teams, so we have smaller teams where it might be 2 devs, 3 devs, or 1 dev in a team, but you still want to modularize a lot more. I think this can be helpful. It just means it's less for you to like think about. For like a medium-sized team, which maybe our business would fall into, I'd say, it just means devs can just not worry about build configuration. I keep saying that, but it's super important, I think. And it just helps devs help the business because they can roll out features quicker. And the larger team is, why do you not already have a platform team doing this for you, is what I'd say. A couple of other resources, because I'm sort of standing on the shoulder of work other people have done. Square, about 2 amazing blog posts talking about called Herding and Stampeding Elephants. Just amazing reads on how to do build configuration and think about Gradle. The Now an Android project is really worth going to. Like, there's so much information there. There's Idiomatic Android, which is an incredible GitHub account and like associated YouTube channel, which is amazing. Idiomatic Gradle, that should be not Android. And the Gradle docs, I learned from this guy that there's actually a lot of useful information in the docs. Now I'll hand over to Adam again.
Thank you. All right, I'll talk about automating or release trains. So a problem that we initially had, and I think a lot of companies have initially, is when you create a new release, it's a very lengthy and manual process. Because you have to announce some kind of code freeze. You have to let people know that they can't merge in anymore because you're about to create a release branch. You need to find and notify the next release captain. And when your team is larger than like 5 people, that becomes difficult. You probably have a rotation somewhere, and you have to go there and find the next person and let them know if they have forgotten. You need to notify the entire mobile org. At least in our case, we have to notify the entire mobile org because we need to tell the translation team to get release notes ready. We need to let them know that we're about to release so they can finalize all our translations, essentially. You have to create a release branch, update version codes, download the latest strings. You have to document these release versions somewhere. At least for us as well, we have an internal place where we document all our previous releases and their release notes and the commits that were included in these releases, so we can come back to them at some point. You have to ensure that every team has their own tests, and you have to ensure that they all pass, and you have to make sure that every team has done their QA if they have any sort of manual flows that they need to go through. And once all of that is done, you got to upload this version to the Play Store. But sometimes teams find problems, and they need to merge fixes for these problems before you actually release this current release. So that means you potentially have to repeat some of these steps again if someone pushes to the release branch or wants to create a hotfix. So we automated it. So the way that we do this right now is we use Fastlane and Zapier and our CI to automate everything. So we have calendar events. These calendar events, they repeat every 2 weeks. And Zapier listens in for these events, and it gets triggered by them. And based on that, it triggers certain pipelines in our CI, on our CI provider. So for example, this will happen, I think, on Wednesday in the morning. So as soon as that happens, Zapier will send we'll find the next person. We'll trigger something on our CI, and it will find the next person that is responsible for handling this release. It'll let them know, and it'll post a public message on Slack to let people know that we have a release departing today. About 4 p.m., it'll let everyone know that the code freeze has been enforced, and nobody should merge anything into master because we're about to create nobody should merge anything into main because we're about to create the release branch. And once that's done, it also creates an entry here. Can you see this? Yeah, it creates an entry. So we have, I mentioned that we have a place somewhere where we store data about all our previous releases. So when they started, who was the captain at the time, the change log. And so it also creates these entries for us automatically. Another calendar event, I think what this does is, it reminds people that the release train is departing today or whenever, and it reminds teams to check out their tests and their QA flows if they have any. And then it creates a branch to merge that, creates a PR to merge that branch back. And once that, so every time you push something to this PR, it uploads a new version of the app to the Play Store, and it lets everyone know that a new version has been uploaded as well. And this is what that page looks like. Another thing we have, which we'll see in a second, is so during that process, before we actually start the rollout, you can, if you're a developer and you find that there's a bug that you need to fix before the release is pushed to the Play Store, you can press this button and it will stop the release. So that means, as long as that state is stopped, nothing else will happen until you resume it again. And once that release is out, if we find after rolling out to like 10% of users or 20 or whatever that we have a critical bug and we need to create a hotfix, all you need to do is click this button, and that button will create a new branch, will do most of these things. Whatever your organization needs for creating hot fixes, it'll do it for you as well. And then you can merge your fixes into that one. And as soon as you close the hot fix, we'll start the actual process of releasing a new version of the app to the Play Store as well. So when that happens, we notify everyone that a hot fix was requested so people know. And we remind teams to declare an incident if they need to. And back to Jordan.
Cool. I'm going to talk about reporting build times and how we've started to do that at M&S. So often found when you're on like the platform team across like the app, you as a dev would be asked the question like, how long do our builds take? Or the team would be asked, how long do our builds take? And the answer has always been, I don't actually know. And that sounds kind of silly, but when you start to think about it, it's very hard to actually bring people's build times locally, look at build times from the CI, and actually understand what's happening. So the solution to this was to build a plugin to report build data to our data engine. And then the goal was to be able to use this data to inform OKRs, start to do some dashboarding to help other teams understand what's happening with their builds. And yeah, that's something we've done. We built a Gradle plugin that would do this. Again, standing on the shoulder of like other people's work, it was very straightforward. So I thought I'd show you how we've done it and the benefits we got from it. Again, it's not a complete tutorial, but I would love to like chat to people if you're keen to do this. We made use of a plugin called Talio, which is not linked to, which would have been a good idea, but I will share it later on. This is a plugin. It's a Gradle plugin which tracks builds, and it gives you access to all the data you could imagine you want. So this is a bit of a video, a bit of an experimental way of trying to demonstrate something. This is creating a Talio, call it a publisher. This is something you can add to their plugin, and they'll send data to it, and then you can send that data somewhere else. And up here we have this thing called a report. A report gives you access to all this information about build time, how much time you spend in the configuration phase, execution phase, anything you could want to know, what tasks were executed in your builds. And it's super useful, to be honest. And there's a bit of a better screenshot instead of moving video, just to give you an idea of the information you get. This is really the most important bit. I didn't have to do much for this. Kind of glue it together into a Gradle plugin, which we applied to our project. And then this starts sending data to New Relic, the tool we use. You could use Datadog, you could use Google Analytics, BigQuery. And this means we can now do dashboarding, which is the hidden discipline of software engineering. If you release a feature, you want to be able to tell people how good of a job you've done, or know if you've done a terrible job and you need to fix something. And it's the same for working on a platform team, or if you're working at a smaller company, if you don't have a platform team, you might need to spend time trying to convince the business to invest in fixing your build times. So we were able to record our average build time of the app. Apparently it went up 70%. Might need to look at that when I get back to work. We also have some other dashboarding, breaking down total time in the execution phase, total time in the configuration phase. This is over a period of a week. So it gives you a good idea of how much time devs in the business spend building things. Another fun one is just total successful and failed builds. You can sort of glean some information and do stuff with this, but it's useful just to track things, get an idea of something that's gone out and it's impacting builds. So how does this actually help developer productivity? I would say it's not directly helping, because just building this plugin doesn't do anything to someone's build, but it helps us realize when things are broken in advance, and that means we can then react and help people. This is great when we have a platform team thinking about it, but it could be useful for the smaller teams. And it helps us build a case for making changes to the build and working on this stuff, which is not easy when businesses want to work on the money-making side of things, which makes sense because that's our job. There is an elephant in the room, and that's called Gradle Enterprise, or it's Devlocity now. It's the best tool you could use for this thing. If you're able to get your business to invest in this, do that instead of do what I've just done. It's an incredible tool. Gives you incredible insights and suggestions, and I recommend checking it out at Gradle.com. which is worth mentioning that. And I'll hand over to Adam now.
Thank you. Oh, another thing about Teliot, the plugin that they use, is it's not compatible with configuration cache. So if you have that enabled, it doesn't work for you. We've made it work on for our team, but through extremely hacky ways. If you wanna if you wanna try it out, we can talk after.
Yeah, that was the other elephant in the room that I forgot to mention.
Yeah, I'll talk about improving our CI workflows. All right. So a few months ago, a problem we had is our CI builds, they took way too long. So our PR checks, they ran in about 30 minutes, which not great. So that meant that our PRs stayed up for a long time because if someone reviewed your PR and they requested changes, that meant the time it would take you to make these changes plus 30 minutes and multiply that by a bunch of developers, you end up every day with like a whole list of open PRs every day. So product iterations were quite slow. And I want to say maybe it made developers not very proactive about requesting changes because everyone knew that if you requested a change, it would mean the other person would have to wait for like 30 or 40 minutes for their code to get merged, and they wouldn't apply your requested changes if they made sense. They wouldn't make these changes immediately because they would wait for other people to review their PR as well if they needed at least 2 approvals or something. So it just made iterations very slow. And another problem is the mobile org did not use the same CI provider as the rest of our company, so that meant we couldn't share anything. That meant we couldn't share anything with that was already built by like the DevOps team or the backend team or any of these teams. So yeah, the first thing we did is we investigated our current CI setup to try to figure out where we can improve it. Quickly figured out that it would be much more beneficial for us to use the same provider that the rest of the company uses, because it meant we could reuse a lot of the logic that they had already written. We migrated to Circle CI, but you don't have to. But I wrote about that. I wrote about what we learned on when we did that. So if you want to check that out, yeah, go ahead. So one thing that CCI allowed us to do is tap into the existing knowledge and infrastructure that was already present in the company. So our DevOps team had already built a lot of one thing that you get with Circle CI that's really cool is you can share these orbs internally. So yeah, our DevOps team had already written things that allowed the CI to authenticate to like AWS, for example, which will come in handy in a second because we didn't have any form of remote build caching on our CI on our previous provider. We had caching; it would cache our dependencies, just the regular stuff that you get out of the box with most CI providers. But we didn't have any remote build cache, and we wanted to do that. But we use AWS internally, and we couldn't authenticate with it because our security team doesn't allow us to create short-lived long-lived tokens. So that meant we just couldn't have an API token to access AWS with our previous provider. But the DevOps team had already built something that allowed Circle CI to do that. So as soon as we migrated, we could build this. One thing, this is a cool project by the Android X team. They had built this because they use GCP, and it allows them to use remote build caches using GCP. But because we use AWS, we just forked that project and wrote our own version of it that uploads our caches to AWS. But then we actually rewrote some bits of that plugin. So now there's a core module that just has the interfaces that you need to implement. So if your company uses Azure and you want to do this, you can just check out this project, implement the interfaces in the core module to have them upload and download from Azure and authenticate to that service, and you should be good to go. Parallelism was really good for us. Before doing this, we had our entire build would run in sequence. So we'd do all these steps, and they would take 30 minutes because they would just wait for the previous step to finish. So we started parallelizing as much as we could. So that's what our CI PR checks look like right now. They take about 4 minutes on average. Another thing is something called fan out. Um, Basically, when you have some workflows that all depend on one bottleneck, you can fan out is when you extract that bottleneck and build it once and then distribute it to the other workflows that you have. So one thing that we do is we run a lot of nightly jobs. So for example, our E2E tests, they run every night. And initially, each one of these E2E tests would build the app, push it to FTL, Firebase Test Lab in our case, and it will stream the results. And that was very expensive because when you build the APK, you want to use a beefy machine on the CI, but then that machine would just wait to stream results, and it would take 20 minutes to stream these results, and credits on the CI are not cheap. So what we did is we extracted that building step, and we run it on a beefy machine on the CI, and then we just distribute it to all other steps. So we build it once, and we distribute that APK to every other step that runs tests for different teams. And all these, the steps on the right side that just stream the results, they run on the smallest possible machine on CircleCI, so that also saves us a lot of money. And during that migration, we removed a lot of unnecessary steps and downloads that were happening before doing this, because on our previous setup was written ages ago, and nobody had looked at it in a long time. So one thing that we wanted to make sure happens this time is we assigned someone to own our CI config. So any changes would go through that person. We have people at CircleCI to help us out whenever something happens, or whenever they announce something new, they let us know. So we're trying to be on top of it as much as possible. In the end, our PR checks, the execution time for these PR checks was reduced by about 80%. Execution time for nightly and E2E test jobs also was reduced by 60%. Uploading new release APKs to the Play Store used to take an hour, and now it takes 18 minutes as well. And yeah, happy, productive developers. It changed a lot of things around PR reviews for us, because when a PR review, when a rerun of on your PR takes 3 minutes, people are just more inclined to review it. People are more inclined to give you suggestions, because it doesn't matter. You can spend an hour or two making these changes, but then it'll just run in 2 minutes. So that's been great for us. And I'll hand back to Jordan.
Cool, thank you. So this is the last one. We're going to talk about linting, which I'm sure everyone's heard about. Linting is a way of making a machine look at your code and tell you what you've done wrong. And in some cases, it tells you how to improve it. So at M&S, we had I wouldn't say it was a big problem, but we wanted to drive consistency in the code base and ensure things look the same. We follow code guidelines, so the Kotlin conventions, for example, is one example, and that's something something we wanted to automate rather than people going through pull requests and saying this doesn't look right, this curly brace is in the wrong place. So that doesn't make pull requests fun, especially when you have to then go make a change to reformat your code, push it up, then wait 20 minutes for the PR to build. So we wanted to be able to make our code look right, catch any bugs, and keep the developer experience good, nice, and consistent. So the solution was to try and lint everything, and this is still very much a work in progress thing. We're looking to adopt Spotless and KT-lint, the Android linter, and some other tooling. A lot of this seems like it's common sense, and it would be something most people would have done, but I have found it's not as straightforward as I thought it would be when we started implementing this. So yeah, sort of repeating myself now, but the goal was to reduce bike shedding and pull requests. We want people to look at pull requests, implementing a feature and focus on the feature rather than the formatting of the code or other issues. We can farm that out to the robot to do that. Not quite OpenAI, but close. We want to keep the feedback loop as low as possible, because if it takes an hour to change something like a curly brace, it's not good. You lose time. It's not very productive. And yeah, we want to pick up as many issues as early as possible, rather than pre-merging, rather than post-merging. So like I mentioned, we picked up Spotless and KT-lint. KT-lint is a tool developed by Pinterest. It's basically a bunch of very opinionated and strict rules around Kotlin. It's inspired by the Kotlin coding conventions. And Spotless is another tool which is like a coordinator of linters. I don't know how best to describe it, but you can add lots of different type of linters to it. And it's been really useful. The reason we like KT-lint is it highlights issues, but can also auto-fix, which reduces like the feedback loop. And I think I've made a mistake with the slide again. And then, yeah, how we rolled it out. I sort of briefly mentioned this earlier. This was easy to roll out once you've done convention plugins. So if you've done step 1, step 2 is pretty easy. We were able to roll it out pretty quickly. Like I said, it was like 300 lines of code, and every module now has this functionality automatically. Some other changes to the CI were required, and like evangelizing for using IDE plugins, like local tooling is useful. We're able to write tests. Like, I think that's pretty cool that you can write a test for your like CI infrastructure, and like you can roll out linting is going to work as you expect. And yeah, repeat myself again, just a version bump, and I don't know where the slides are gone. I think that might have been something to say we're at time, maybe.